Good morning. Today we will be discussing about vector mathematics. What are vectors? Vectors are represented by an arrow with both magnitude, which is the measure, and the direction, which is the angle. We will be discussing this later on. Vectors can have units such as displacement, velocity, acceleration, force, etc. These are different from scalar units, which is mass, length, distance, and so on. Then the fact that vectors have direction and scalar do not have direction. Now, let's discuss about magnitude, the thing that both scalar and vectors have. It answers the question how much, and it's basically the measure of something. For example, the distance from A and B below is 5 kilometers. Therefore, we can say that the magnitude is 5 kilometers. Directions. What are directions? Basically, it answers the question, where is it going? It can go north, south, east, or west, as shown in here. You can see this in compasses and maps. Secondary directions, basically combining primary directions. For example, northeast, northwest, southeast, and southwest. Tertiary directions are directions relative to the four primary directions, for example, north of east, east of north, west of north, and so on. Basically, you take a direction, for example, east, and then you go northwards to have to gain north of east, and then go southwards to have south of east, and so on. Now let's talk about using angles and directions. We are given that the angle is 30 degrees, and that it is from the east axis. It is measured starting from the east axis and we're going north. Therefore, we can say that the angle is 30 degrees going north of east. Now, how about this one? We're given that the angle is 75 degrees and it is measured from the east axis going south. Therefore, we can say that the angle is 75 degrees going south of east. Now, let's combine magnitude and direction together to form vectors. Now, before we discuss about vectors, I need to discuss about direction graphs. North and east are associated with positive, and south and west are associated with negative, as shown in this graph. Now, let's learn to express the vector. We are given here that the magnitude is 5 meters, and that the angle is 53 degrees relative to from east, it goes north. Therefore, we can say that the vector is measured as 5 meters, 53 degrees going north of east. Now, let's find the location of this vector in the Cartesian plane. The magnitude is 5 meters, the angle is 53 degrees relative to east going north as usual, and that the adjacent of the angle is basically, it goes east, the adjacent of the angle, and the opposite of the angle goes north. Therefore, you can use cosine for the adjacent in finding this, the measure of the east. So we just multiply 5 times cosine 53. It goes 3.01 meters to the east, and we do similarly but sine for going to the north, and we can see that it is 3.99 meters to the north. Now, that's just one vector. How about two vectors? It creates a unique vector with the new magnitude that isn't from the either vectors, and this line we call a resultant vector. Now, this is an example of a resultant vector. What are we given? Given vector A, which is in red, 4 meters, 60 degrees north of east, and vector B is 6 meters, 10 degrees north of east, and vector B starts from the endpoint of vector A. Very important. Now, vector A located at this coordinates. We use the tactics from earlier to obtain that 4 times cosine 60 is 2 meters to the east. And using sine, we can find the one in the north, which is 3.46 meters. Similarly, we can find the results for vector B, but instead we are measuring 10 degrees instead. So it's 5.91 meters to the east and 1.04 meters to the north. Keep that in mind. Next, as the resultant vector is just the sum of the vectors, we add the values of the magnitudes, basically the how much to the east they go and how much to the north they go. Note, the north and the east are positive while south and west are negatives. Now, we know that the resultant vector is located at this to the east, which is 7.91 meters to the east, and 4.5 meters to the north after adding the coordinates up. Now that we have those numbers to the east and north, we can use the Pythagorean theorem, which results as 9.1 meters. And using the inverse tangent or the arc tangent, we know that the angle is now 29.66 degrees. The resultant vector is 9.1 meters pointing at 29.66 degrees north of east. Note that when dealing with negative numbers, for example, your answer is a negative number. For example, negative 14 meters, then 30 degrees south of west. That is not correct. We need the absolute value. So we need 14 meters instead of negative 14, then south of west. That is acceptable. Notes. The results may not be very accurate because of estimation. We are estimating after all using cosine and sine because we cannot we cannot list the entire decimals because it's infinite. And we need to learn how to round off correctly so that it's as accurate as possible. Vectors are also applicable to non-distance units. It's not just meters, it can also be newtons, meters per second, kilogram, meters per second, and so on and so on. In conclusion, vectors